Welcome to the Embryo Strategy Training presentation. As you know, breeders are increasingly looking to embryo production and transfer technologies to further increase the rate of genetic improvement in their herds. The new myStrategyEmbryo module was specifically designed to satisfy this demand and provide CEMEX reps with a new tool to engage and advise clients. Over the course of this training, we will cover some of the basics surrounding the different embryo strategy types, as well as the underlying framework of the myStrategyEmbryo module, including the general setup, input structure, and a little bit of the internal mechanics. Following this presentation, the solutions team will perform a live walkthrough demo of the system. To start, let's first consider embryo transfer technologies. What are they, and how are they applied? Embryo production and embryo transfer are a class of advanced genetic breeding technologies that improve reproductive efficiency and increase the rate of genetic improvement by essentially producing more calves out of the best females and bulls available to the herd. There are several different types of embryo transfer technologies, but they all essentially consist of two major components: purchasing embryos or producing embryos from donor females, and transferring the embryos into a recipient female, which gives birth to the calves. Conventional embryo transfer, in vitro fertilization, and purchased embryos are three distinct types of embryo transfer technologies that each differ in the process used to produce the embryos. For instance, if we consider conventional embryo transfer, that process consists of a superovulation protocol followed by artificial insemination, flushing of the embryos, and then transferring them to the recipient female. For in vitro fertilization, or IVF, superovulation of the donors is still used. However, those oocytes are then extracted from the donor female, and fertilization and maturation then occurs in vitro at the lab. Once complete, those embryos are then returned and transferred to the female recipient. And then finally on the right there, in the case of purchased embryos, breeders purchase embryos from a provider such as Bovatech and then transfer them directly to the recipients within their herd. Now, understanding the key differentiating elements, such as the economics or the resources required to implement a given embryo technology, is essential to selecting the appropriate strategy for a customer and becoming an effective genetic consultant. The table on this slide summarizes some key characteristics across the three strategy types. Differences in embryo production capacity and collection frequency are particularly relevant when donor collection is involved. Importantly, we can also see differences in pregnancy success rates and a little bit more significant differences in the resource requirements. We have a range of needing a simple trained technician to, in the case of IVF, needing an accredited veterinarian. Now, depending on when a breeder wants to begin collection on their donors, IVF might favor conventional embryo transfer. As we can see, we can start with a little bit younger cohort of animals under the IVF model. Embryo costs are a major consideration for any strategy, and we can see the range of values presented here. Depending on which strategy you pursue, you can have a range of 100 to around 190 USD, or if we shift our focus to the purchased embryos, depending on which product line you go for, we can have something as expensive as 450 for those biopsied elite, or in the case of our biopsy genetic, 225. In building off of the information from the last slide, this diagram puts into context the embryo program spectrum and shows the different levels of involvement that exist. The left side of the slide serves to highlight those embryo-based strategies that involve purchasing embryos. In its simplest form, this can be beef embryos, or if we consider the production of dairy replacements, we have that range of dairy embryo products, such as on-demand, biopsied genetic, or biopsied elite embryo packs. On the right side of the diagram, we see more intense embryo programs involving the production of embryos from donors within the herd. And this can be achieved by conventional embryo transfer or by IVF strategies, whereby those oocytes are being shipped to Bovitec for IVF and then later implanted. Putting together the information presented on this first set of slides, we've hopefully developed a better understanding of the embryo strategies that exist within the industry, as well as their defining properties. From here, we can begin to consider how the sales of embryos or the implementation of an embryo strategy can be assessed for a given customer. When we consider the sale of embryos, we should always begin with defining the client's goals. And from there, we can then look to assessing the current herd's genetic level using genomic testing through a program like Elevate. From there, we can then look to calculate what the genetic improvement or the return on investment can be for a client based on their strategy selection. Now, conveniently, this is exactly where the myStrategyEmbryo module delivers. It's designed to evaluate multiple different herd female strategies that incorporate embryos. And what it does is it quantifies that added genetic benefit that can be introduced by using one of these more advanced breeding technologies. So with all that said, let's delve into the framework details of the myStrategyEmbryo module. The myStrategyEmbryo module is an optional component to the existing female strategy module that incorporates IVF embryo transfer or purchased embryos when solving for the female herd strategy. It serves as a strategic tool by assessing various embryo strategy scenarios, even including combinations of embryo programs. It uses embryo program-specific parameters. In the case of conventional embryo transfer or IVF, these are things like the number of donors per collection or collection frequency. And for something like a purchased embryo strategy, this includes the number of embryos purchased per year, purchased embryo type, and that purchased embryo cost. Now, in addition, as a strategic tool, what it does is it derives an optimal strategy for maximum profit. It's looking at what proportion of recipients should be included within the strategy based on the number of donors on collection or the number of embryos purchased within the year. And finally, like the existing female strategy module, it continues to allow users to override values for the proposed semen groups or donor purchased embryo counts, and then re-optimizes to be able to facilitate the ability to create custom strategies. Incorporating the embryo module component is simple. It consists of selecting which strategy you want to evaluate and providing the system with any additional strategy-specific input requirements. Embryo strategies can be easily added or removed at either the initial configuration of the female strategy or through the customization screen using the button Add Embryo Strategy at the top right corner. It's important to note that each embryo strategy possesses its own unique input requirements. These additional inputs, much like the ones in the My Dairy screen, are required to tailor the optimization engine outputs to the herd's profile. And so in the next set of slides, we'll kind of walk through the individual input requirements of the IVF, conventional embryo transfer, and purchased embryo strategies offered in the system. The required inputs for an IVF selected strategy are shown on this slide. Similar to the structure of the myDairy inputs, we have a range of mandatory and optional fields. When we look at those mandatory fields, we see that the first two are related to embryo costs. So we have two separate components. The first one, the IVF embryo cost, really encompasses anything related to housing, donor prep. That includes things like hormone treatments, FSH shots, as well as vet costs. The second component is the embryo transfer cost. If we look down the list of inputs, then we have whether or not the cows will be used as recips, the percent implants, so this is the proportion of embryos produced that will be used on farm within the same year, embryo conception rate, so this here we're looking at the 60-day conception rate. Then we have next breeding after embryo, so this will be a choice between beef conventional and sexed. Collection frequency, so the number of times we're collecting donors per year. And then the average number of IVF embryos per cycle. So that's going to be your embryos per donor per cycle count. The semen type. The IVF semen cost per dose. Value of genetic sales. So this would be representative of the estimated yearly revenue from IVF genetic sales. And then the current number of donors per collection. This field in particular is really critical to the engine because it plays a key role in determining what range of donor count scenarios the engine is going to evaluate. And we do this in an effort to make sure that the scenarios that the system is computing make sense and are in line with what the herd is already applying. Optional fields for the IVF strategy include percentage live calves, which represents the proportion of live calves expected from IVF embryos, and secondly, the semen doses per cycle. Now, something to keep in mind when completing the semen doses per cycle input is that recognized efficiency associated with IVF and the use of a semen dose. So what you're going to see when you try to enter a value here is that the default is set to 1 dose and the upper limit is capped at 5. And so just be certain that if you choose to complete this optional input, that you have a grasp and a general understanding of what the semen dose requirements are based on the current average number of donors per collection and that collection frequency. The input requirements for conventional embryo transfer are very similar to those for IVF. Again, we have mandatory and optional fields. And within the mandatory fields, we begin with those two components associated with cost. That first component, the ET embryo cost, is going to encompass housing, donor prep, and vet costs. The second component is specific to the embryo transfer cost. Next, we have whether or not cows will be used as recips, the percent implanted, so again, that's a proportion of embryos produced that will be used on farm within the herd, or within the year, and then the embryo conception rate, 60 days, next breeding after embryos, the collection frequency, so the number of collections per year, the average number of embryos per cycle, so embryos per donor per cycle, the semen type, the embryo transfer semen cost per dose, the value of genetic sales. So this time we're looking at that estimated yearly revenue from embryo transfer genetic sales, and then the current average number of donors per collection. Again, just like the case was for IVF, this is a critical value for the engine in determining the range of scenarios that will be evaluated. This is done to make sure that the scenarios evaluated align with what the herd is currently doing. Again, optional fields include the percentage live calves. So that's that proportion of live calves expected from conventional embryo transfer embryos. And then we have the semen doses per cycle. So this is the number of doses that we would use. Now, comparatively to IVF, you'll notice that the default value here is going to be set to 3, and that's because we recognize that the conventional embryo transfer method is a little less efficient with the use of semen. Unlike IVF and conventional embryo transfer, the inputs for purchased embryo strategies differ slightly. The mandatory inputs consist of purchased embryo type. Specifically, this relates to the embryo product lineup offered through Bovatech. Currently, the system supports on-demand, biopsy genetic, and biopsied elite products. And in the case of a selection of on-demand, there's an additional input requirement where you specify the semen type being conventional or sexed. Additional inputs to the purchased embryo strategy include those purchased embryo cost, which should be aligned with what the embryo type selection is, as well as those embryo transfer costs that we saw with the IVF and conventional ET strategies. The next input is a familiar one. It's the confirmation of whether or not cows are going to be used as recipients. The one following that is the next breeding after embryo. Again, beef, conventional, and sexed will be your options. Next, we have the current number of embryos purchased per year. And something important to note here is that when you're completing this input field, you'll notice that there's an increment to this input that only allows you to set values that are multiples of 4. And this is going to correspond to the pack unit increment value that's going to be supported in CMEX Go. In the case of purchased embryo strategies, there is only one optional input, and that's the embryo conception rate. Once the inputs are incorporated, the engine now additionally optimizes for either the number of donors per collection, or in the case of a purchased embryo strategy, the number of embryos purchased per year. These new solutions parameters can be found on the bottom portion of the custom strategy summary tables. When an embryo strategy is active, you'll notice that the recipients row in the middle of the table will be auto-populated based on the number of donors or purchased embryos recommended within the solution. Now, the recipients' percentages are calculated as a function of the embryos produced by the donors that will be implanted within the year. The same goes for the purchased embryo scenario. It's going to be a function of the embryos purchased within the year that will be implanted within the herd. The setup of the engine differs slightly between the recommended and the custom strategy options. Under the recommended pathway, the engine uses the inputs to create and run different optimization configurations that account for varying donor or purchased embryo counts. For instance, it would run separate scenarios for donor counts ranging from 1 to 5 and return the output with the highest overall net benefit. Under the custom pathway, a single configuration defined by the user is run. Under the recommended option, the engine has embedded a looping configuration with minimum and maximum thresholds. The minimum threshold is calculated as 75% of the input value for the current average number of donors per collection or the current number of embryos purchased per year. The maximum limit, or that upper limit, is calculated as a function of the maximum number of recipients that could be implanted within the herd. What's important to note here is that under this structure, that no donor embryo option is only considered when the average number of donors per collection is set to 0. Otherwise, that minimum threshold of 75% will never cross that 0 value. Now, for the custom strategy, on the other hand, since the user defines the donor and/or the purchased embryo values, the engine essentially treats them as locked fields and run them as a fixed embryo scenario. We'll explore the application of this framework in more detail in the live demo portion of the training. Thank you for your time and attention. If you have any questions related to the content covered in this presentation, please don't hesitate to reach out to the CMEX Solutions team with any embryo module related questions.